My name's Mark. I'm the CEO of the app development agency Margelo. Shout out to all the Margelo guys here. I see all of you. I'm excited to be here today to talk about JSI modules. We'll be taking a closer look on the JSI side instead of the TurboModules side. I know there's not much examples for TurboModules, but there's some parts of JSI modules that I haven't talked about, and there's like no documentation on it. So I wanted to talk about this a little bit more to give you guys an idea of what they can be used for. Instead, because TurboModules doesn't cover like everything you can do with JSI. For those of you who are not familiar with it, the old bridge, which is the communication between the JS part and the native part, it is similar to a REST API, not in a literal sense, but you can understand to make it a little bit more understandable, because you're passing in data as JSON, and it's similar to a black box where you just pass it in. The native part kind of picks it up as a response and then calls back to the JavaScript side. Yeah, that's nothing new here. The new bridge uses JSI, where you can use synchronous method invocation to basically call a function on the native side synchronously from JavaScript as if it was a native function that's embedded in your JavaScript runtime. We also notice from the web there's something similar on the web as well to access native browser data through JavaScript. Okay, so let's take a look at an example. We want to build an image manipulator native module thingy, and we want to make an image grayscale. We want to make it blurry. We want to get an image size and potentially resize the image. To do this right now, you would have to pass in an image URL as a string, and then the native side kind of handles the actual grayscaling, blurry, whatever. So we open the image picker, which is a native function. The user picks an image, and it returns us an image URL, which is a string. It's a file URL. The image is stored on your local file system. We then want to make the image grayscale. So we pass in the image URL to the native function. The native function is called makeImageGrayscale. And yeah, we await until that's done. Then we do the same for the makeBlurry. This is, by the way, all pseudocode, so some of it may not compile on your end. Then we get the image size, and if it's larger than 4K, we want to resize it down to be 4K. Let's take a look at how this would, and we can display it in a view as well. Let's take a look at how this would look in a pseudocode native component. I'm going to use Swift for this because it's more similar to JavaScript than C++. We have some C++ samples later on as well, so don't worry, but let's just try to use it in Swift. We have all of those functions that I just mentioned, and let's try implementing makeImageBlurry. So we load an image. As you know, we need to load the image to the memory, because you can't just make an image blurry by directly writing to the file system. You want to have it loaded in memory, or you need to load it in memory to work on the image. And yeah, that's what we're going to do. So we load the image from the file system. That's an I/O operation, input-output operation. We blur the image, and we write it back to the file system. So some of you may already realize that this is a lot of I/O operations. We're loading the image, we're writing in memory, this step can't be skipped, and then we're saving it back to the file. And if we implement all of the methods, you can see that I'm repeating myself quite often, and it's a lot of I/O operations. So back to the JavaScript side, we can see that by calling open image picker, make image grayscale, make image blurry, get image size and resize image, and then displaying it in a component, we have 5 times I/O operation for loading the image and 4 times I/O operation for writing it back to file. This is completely unnecessary. Wouldn't it be cool if we had image type, which we can use in JavaScript to have the image as an actual instance, so we can work on it in memory instead of like reading from file, writing, and writing back to file again, which is unnecessary. So that's what JSI allows you to do. We have an image type. I'm going to leave it unknown for now. You can obviously type it, but technically it's a more advanced, complex type. We're just going to imagine that it has like width, height, and buffer, pixels, planes, whatever properties on it. And then we can replace the image URL with the actual image type. So how does this look on the native side? instead of the image URL parameters, we can use UI image directly, and all of the I/O operations can be gone. So now we only have the in-memory operations, and we call those functions using the image. We don't need to copy anything. We don't need to load it again into memory. We don't need to write again to memory. It's all happening in memory. That's obviously cleaner. It's more logical code because that's how you work in native app development as well. You load it once, you do all your operations, and potentially write back if you need to. And it's faster performance. Because we don't need to go back and forth for all of the file I/O. It makes more sense. So let's take a look at another example. We have an audio player. We want to play a song, and I don't know, I think the SoundCloud app has this where there's a waveform representation of the song. And for that, we need to have a sample buffer callback. It sounds complicated. In reality, you're just streaming the bytes as the song plays. Really simple stuff. And with the current architecture, you're going to have to pass a string around. A string representation of the buffer. We're hitting the same problem as before. If we think back again, we have to pass strings around and can't really use the native instances, like the actual objects instead. So this is again really slow. We can optimize this because right now the calculating loudness stuff and visualize a circle. It's just for representation, just to make the circle smaller and bigger. By the way, there's an example for this on the Expo repo. I made a PR once where this is kind of implemented. So if you want to actually run this code, it works on Expo. You can check it out later. I think I can provide a link somehow. But let's focus on the overview here. On the native side, we have the same callback here again as before with the image module. It's basically the same story. You pass in a string. Before it was the image URL that needs to be loaded. And now it's passing back from native to JavaScript. So it's the same, but other direction. Where we have the actual sample buffer as a byte array on the native side, just as we had the image on the native side, we need to marshal it to an actual string so it can be passed over the bridge. That's not fast enough, and it's not very logical. So instead, what if we could pass the byte array directly over the bridge, just like how we could pass the image directly over the bridge? That's another example here where you can pass the buffer directly. In this case, this is an actual array buffer. So it's not a byte array, it's a JSI : array buffer that's being passed over the bridge. And if we take a look at the JS side now, instead of having a string buffer that we need to convert to an array buffer for us to actually operate on it, we can now directly accept the array buffer. In this case, it's a uint8 array. If you're familiar with array types, there's different types for all of the numbers you can store. So yeah, again, this is just a second example on this. You don't need to understand the whole code. So we can, instead of passing around strings that need to be marshaled and serialized and deserialized, we can instead pass objects directly. Those objects can have properties. Either it's an array buffer, like a common object that's already being used in JavaScript, or the image. Yeah, that's all possible because of JSI. You can pass the array buffer directly. You can pass the image directly. It's faster. That's point one, speed. You can use all the data types from JS. So for example, array buffer. You don't need to marshal everything to a string because that's the problem with the bridge. I'm sure you're all familiar with it. You can pass the types directly. And you can do runtime magic. I'm not going to show you all of the runtime magic. There's some parts that are really weird. So you can work with a garbage collector. You can do profiling on the runtime. Some parts are really interesting. Reanimated does some runtime magic. I'm not sure if anyone here has actually investigated the C++ code of Reanimated before, but the worklet part is kind of black magic. They take a function, they rewrite it using a bubble plugin, and then move it to a different context to run it there. That's some kind of runtime magic, I would call it that. So yeah, JSI obviously has a lot of benefits. I think we're all aware of that. Let's take a look at one more example before we take a look at the actual C++ implementation here. We have Vision Camera. I think you guys know Vision Camera. I created and maintain it. It's a camera library where you can stream frames in real time using a frame processor. So a frame processor, if you open your camera and look around here, you get all of those frames in. It's running at 30 or maybe 60 FPS. and we want to do some JavaScript code on every frame. For example, we want to, I don't know, see the average color that the camera frame is currently seeing, or we want to detect faces here. We want to do this magic in JavaScript instead of writing all of this in a native app. What if we use the bridge for this? Well, it wouldn't be fast enough. Imagine if you were using a modern iPhone, well, I don't know what's the latest version, 13. The camera is streaming 4K frames at 30 up to 60 FPS. If you're streaming 4K frames, that's 10 megabytes per frame. And if you want to pass 10 megabytes of data, if you want to serialize 10 megabytes of data into, JSON array buffer, aka a string, and pass it over the bridge, receive it on the JS side, decode it there again, that's not gonna fit within 16 milliseconds that you have time for each frame. So you need another approach. Again, JSI to the rescue. Oh yeah, here another example, detect faces. JSI to the rescue. We can take an actual camera frame and pass it from native to JavaScript. So this camera frame is an actual complex type. It has a native implementation, so it does not, it's not in a JS file or something. It has a native C++ class that looks kind of like this. So I removed some parts that aren't really necessary to show here. But in reality, this code is taken from Vision Camera. It is the frame host object that's deriving from JSI host object, where you have two important functions. First of all, you have the constructor and the actual frame, native frame type. Those are just for constructing it on a native side. But you can pass this object, which lives in C++, directly to JavaScript, and JavaScript can access props on it. So two important functions: get and get property names. Get property names is pretty obvious. If you have the property width, height, toString, whatever on it, this returns you a list of all the properties that this object has. And get actually accesses the property. So frame.width calls the get function with the name, second parameter being passed to it, called width or height or whatever. So for example, if we do frame.width, if we log this, then it would call this function right here. That's the implementation now. Before I showed you the header, the declaration. Then now we call the get function. The name is width. It's passing in the name width, and we write our native code just like we used to. So this is getting the CV pixel buffer for the actual pixel buffer. You don't need to understand it. It's not complicated, but it's just a native implementation of getting a frame buffer's width. And then we just return that to JavaScript. So really simple stuff. You can read this value in JavaScript. It's a normal double. It's synchronous, as you probably already noticed. You're accessing it just like any other JavaScript property on any other object, but it has a native implementation. So yeah, we can pass this object, which contains a 10 megabyte frame, directly over the bridge, run some code on it, like console.log_frame.width, and then get to the next frame. And this can actually run at 240 FPS plus, depending on how fast your code is, because there's no copying involved. There's simple object construction, but the frame itself is not being copied. It's not being serialized. Nothing. It's just being passed directly to JavaScript. So this takes, I think, 1 millisecond or something on an iPhone 11 Pro in debug mode to pass it around, which is fast enough. If we want to run it at 60 FPS, it's 16 milliseconds. Yeah, edge data, I guess. So yeah, we just know we know that we can pass instances or complex objects around from JS to native. We can also do the same by creating an instance from JavaScript, and the implementation itself is happening in C++. For example, I'm not sure if you guys are familiar. MMKV is a storage library. I created React Native MMKV, which wraps the actual MMKV library, and you can set keys. Values. It's a simple storage library. not much to it. Now, how is it implemented? How can I create a new MMKV instance, which is actually a host object? Well, it's pretty simple. We have a class that just kind of wraps this to provide types with a constructor, and in the constructor we're creating the actual native instance. I'm using. This is a little bit hacky. This is where JSI modules are a little bit hacky, because you're injecting stuff into the global namespace. So, if you create a JSI module, or if you take a look at React Native MMKV, it's creating the function mmkv create new instance on the native side and injects it in your global runtime. This is, again, a little bit hacky. That's why TurboModules are to the rescue. They have some, collision prevention and all of those kinds of things. So in general, yeah, I'm coming to the conclusion later. Let's take a look at the mmkv create new instance function. Oh, okay, sorry. Actually, let's take a look at the mmkv host object first, because this is the object that's actually being stored in the native instance. So as we see above, private native instance, this is actually a native class, as similar to the frame host object. This has the same implementation. We've seen this code before. It's a host object with get and get property names. And yeah, we can create this using, this is just boilerplate code. I always copy this. It's the same for every native function. You can just create a new instance of the host object, as I do here, using the normal constructor, the constructor that you write yourself, and then just return it as a JSI object. And that's it. We inject the function to the global namespace, as I said before, and now we can just call this. A native instance is actually holding the host object. So yeah, that's how we create instances or host objects from the JavaScript side. Very easy stuff. We can now use this native instance to set or get the data, like the mmkv implementation. So set, I don't know, username or whatever. We can now wrap this in our mmkv class, which is on JavaScript, but actually call the native implementation. So when we call the native implementation, it, again, nothing new here, calls the get function with the prop name being set or get. Again, the boilerplate code here for the host functions. And then you just implement the native functionality of whatever this function should do. In this case, it's setting the value to the native mmkv instance or getting the value. This is the same exact thing as on the frame host object, where you can get the width or set anything, I guess. So to use this on JavaScript, we again create a new mmkv instance. We use set the name to Marc, get the name, and log the name, and it logs Marc. So very basic stuff, but it's actually implemented in C++. You can do lots of powerful stuff with this. You don't need to serialize anything anymore. You can pass everything directly. You can use host objects, and the native objects can be exposed to JS directly. So this is really useful for these libraries. Just as an example, there's many more libraries that are making use of this. Big Number is another library we created. It allows you to store big number instances. I'm sure you're familiar with bn.js or other JS implementations of Big Number. They often store the numbers in strings. So Big Number in general, it's storing big numbers. For example, if a double doesn't hold the number or isn't big enough, 60, then a big number is just storing virtually infinite numbers. And React Native Big Number is a library we created at Margilo that also allows you to create those big numbers, but it's way faster than any other JS-based library because it's using a host object implementation. I think we've benchmarked it to be around 30 times faster. I have to check again before I talk bullshit on camera. Yeah, reanimated obviously as well, with the UI worklets, but we've talked about that. We've seen React Native mmkv and Vision Camera as well, and JSI images proof of concept implementation that I created on GitHub. You can check it out, basically to pass in UI images and pass them around. Yeah, the problem here is TurboModules don't have an API to create host objects yet. You can use TurboModules, or you can write TurboModules today, and your TurboModule itself is one host object, but you can't pass a host object like an image or an mmkv instance or a big number or a frame from Vision Camera to one of your native functions. There's just no API for it as of today. So in this case, mmkv, I can't rewrite mmkv to TurboModules, or not very easily, because I simply can't create the host object using a TurboModule. In this case, I needed to use JSI directly. Same for Vision Camera, same for JSI image, same for Big Number, and same for reanimated. In general, we just covered edge cases. Those aren't really, things that you need to do on a day-to-day basis or in a normal React Native app. Those are really, really rare edge cases. You probably won't need to use JSI directly at all. There will be TurboModules or you might need to write some TurboModules at some point. They're really simple. The API is in Java or in Objective-C, or I think you might be able to use Swift as well. So it's really simple stuff. TurboModules allow you to, kind of like wrap JSI without all of the weird JSI stuff. But you probably won't need to use JSI directly unless you're trying to do this weird edge case thing and have a similar library, maybe a library that's faster than React Native MMKV. I doubt it. Yeah, so if you don't need to pass those custom native types around, use TurboModules. You can pass strings, you can pass numbers, booleans, objects, arrays, all of it to TurboModules. Yeah, simple stuff. And if you really do need to pass custom native types around, if you really need to, I don't know, do lots of image manipulation, and you need to do it today or like right now, then you might need to use JSI modules unless you really want, or the trade-off of performance is not a big issue for you, because again, the file reading and writing might be, slow depending on how often you actually call this. For example, I don't know, on Instagram, assuming you would put the sticker on there and actually write it to file every time, that would probably be too slow if you move a sticker around or whatever. This is just the state today. In the future, TurboModules might support creating host object types. I know that TensorFlow Lite from Facebook needs this. They are, by the way, if you haven't checked it out, it's really cool. It allows you to run, TensorFlow models on React Native or using React Native. And you can run, for example, inference directly on a camera. And yeah, that's one case where they need to pass the images around and need JSI host objects for TurboModules. And I'm sure they're going to work on it and integrate this into TurboModules. I don't have any official confirmation of that. That's just what I'm thinking. But yeah, so that's the state of it. And a pro tip from me, keep an eye on Expo Suite API. It's an API that's very similar on both platforms, iOS and Android. You can write simple JSI modules or Expo modules using Swift and Kotlin. It's a very similar API on both platforms, and they definitely have support for host objects planned soon. But you need to use Expo as a dependency for your projects. This would be obviously really cool because then you can pass the native types around. And yeah, I guess there needs to be some sort of standard for libraries that provide a type, like low battery, okay, like UI images, for example. Yeah. Thanks for listening. I'm sorry if this was a little bit too fast. I think we're on a tight schedule here with three speakers today. Follow me on Twitter, on GitHub, on LinkedIn, on Club Penguin, whatever. Follow Margelo, my agency, and contact us for consulting, app development, performance audits, whatever. Thanks, everyone, and see you guys later in the pub.